Okay, so there's been some testing being done on the internet regarding whether the screws in the stock hot end make that much of a difference, whether they're in or out, especially considering that this cover is so bad at directing the air on the hot end. So we're going to do a couple of experiments. We're going to heat it up, take a reading. We're going to take the screws out, take a reading. We're going to put a little cold weather kit on the bottom of this to direct the air better on the hot end, see if that makes a difference. So we're going to start by heating this up and letting it sit here hot for about a half hour, just so everything balances out. So I think we're going to go for 225 is what I'm going to go for a setting here on the heat. Alright, the time is 8:51. We'll wait until about 8:10 and we'll give this a shot. Okay, so it's been here running at 225 for slightly over 20 minutes, and we're not off to the best start here. So he said he had it 60% down the get a Creality hot end to look at here. So he said he had it 60% down the tube. So I think I have it at least 60%, if not even further down. And I have significantly lower temperature than him. So he was claiming 68.6 degrees Celsius. I got 42. Let's take a look and see how long this is, how far this is down in here. And yeah, as you can see, I even have it bent to make sure it's touching the wall. I am well past 60%. Well, 60 to 70. I'm probably 70% down there. So, but I'm at least as far as he was. Slide this back in here. Okay. I just have the tape on here to make sure that nothing moves, so we get consistency. Alright, let's just go back up to where it was, and then we'll reach up underneath here and zip these screws out. Alright, so what I'm going to do is I'm going to move this here. So you'll actually be able to physically see the temperature change as the screws come out. I think that's about what we had before. You reach up under here, get our sock off here. So, and our sock is off. And let's get up in here. Well, dirt to dirt. Trying to. Alright. Comes screw number one. Now, here comes screw one. And here comes screw number two. Now the screws are definitely hot. Ain't no doubt about that. And she is definitely dropping. So he was getting a split of, we'll give you 67 on that, 77, about 14-degree difference on his. So I'm doing this because I just detected something that didn't seem right to me. Not necessarily the science, but the process. So, oh, this is necessarily, not necessarily. We're going to put this sock back on here. We'll see if it goes back out with a sock. I doubt it. Alright, so there's your sock. So, yeah. So we're looking more like 6 degrees, less than half of the difference he was claiming. So I have some more magic, more ideas. So what I'm going to do is I'm going to put some of this blue tape right here underneath this hot end. It's basically what I call a cold weather kit. I usually use foil tape. What happens is when it gets cold in your printing environment, this air will bleed out onto your print, and if you get really cold like it can be, you know. Oop. That's a little bit of cup. Wrong end. Okay. Pretty stable. Tape's not making that much of a difference. I'm actually a little surprised on that myself. So, let's get back up underneath there and pull our sock off. Yeah. Not burning myself here if I can do it. Alright. 36.7 is where we're at here. And let me put my cold weather kit back on here. They make a bracket, a plastic bracket that you can get. It's supposed to snap on here. It's a print. I've seen it at Thingiverse. Put a little another piece on here. So there's my cold weather kit. And we are creeping back up. I really would like to do this with a different fan shroud. That would be pretty cool. We'll see. I feel like the tape's going to be good for something with the air running across there. One thing to remember is while the room is a certain temperature, area around this area right here is going to creep up a little bit. I wouldn't expect it to throw off the readings too much, but it could get a little warmer in that location. So it looks like our cold weather kit was good for at least like 1.7 degrees. We'll give this a few more minutes to see where this wants to go to. So the cold weather kit made a difference. I imagine it would make a difference without the screw too. So the drop you see here, um, curious. Let's pull this tape off and see if this gives us our last degree and a half. See what happens with that off there. We are climbing faster than we were climbing with the tape on there. Our climbing pretty much stopped. So you see we are climbing. So it looks like that cold weather kit or tape, whatever you want to call it, is good for about 1.7 degrees, best I could tell. I feel like if you put a better Hotend fan that targeted the Hotend better, we would even get a less, it would even be a, it would be less of a split. I think it'd even be less than 6 degrees. I think you get down to, 3 or 4 degrees Celsius between the screws and not having the screws. So I'm happy with the results. It's what people thought. There is a difference, but it is tiny. All right. We're also talking about 47 degrees where that probe is, or 42. That's, that's not hurting your filament or causing any problems. So it's apparently a problem that doesn't need to be fixed. And if it did need to be fixed, if you had a problem, the way to fix it would be to go ahead and address your fan cooling. I just threw the tape back on there, see if it wants to drop down a little bit. Looking for it to stop climbing here. Doesn't want to stop climbing. So basically what's going on is this thing's going back to the original reading, if I remember correctly, was 42.7. So I believe that's where it's trying to go to, and that anything under there is the effect of the better cooling. So with 210s, the other possibility is that as we heat this up more and more, the heat spreads throughout the material we have here, and that slightly makes the area around here warmer. It's going to throw off our temperature ever so slightly. And that might be what we're seeing now. We might actually be a little bit hotter because we've been running longer. Just an accumulative effect of the heat. So, I believe if we pull this off, it'll start racing right up here, a couple more tenths. I mean down. There you go. Or no, up. It should go up. Dirt, dirt, dirt. Let's get all the tape off there, scientists. Some of what you're seeing here is the element cycling on and off too. Should have brought an amp probe in. Could have hooked that up. So you see our temperature is going down, but is that our element cycling on and off a little bit? But there you go. Less than half of the stated difference at 225 degrees Celsius and shop pretty close to room temperature. All right, good luck everybody. Okay, so I just looked again and he did his test at 250. Slight oversight. I blew up one of the pictures and I could see his screen. So we're going to go ahead and pop this thing up to 150. And we are at 150 now. We are just waiting for the heat in the hot end to catch up. But we're already seeing significantly lower temperatures than what he did. So according to him, at 250 with his probe, 60% down the heat throat or the throat, he read 81.7 degrees. So as you see, the screws are in right now and we are at 45.3. So I'm slightly confused with why his temperatures are so high. We're going to go ahead and just let this sit here for about 10 more minutes. I suspect we'll probably squeeze another degree or two out of it, but that's probably it. We'll go ahead, heat this up, and then we'll pull the screws out and see what happens. Oh, obviously, yeah, I have the screws in. I should be at the hot end. All right. Okay, so we're pretty much bouncing between 45.9 and 45.7. That's probably when the element cycles on and off. We're going to go ahead and pull our screws out. See what happens here. That boy's going to be a little bit hotter this time. Alright, so there's your screws out. And let's see where we race to. We're coming down. So we had about a 6-degree split on the test at 225. We definitely could be looking at a bigger split, but I don't believe it's going to be more than 1 or 2 degrees. We're going to see. His temperatures are way high for some reason. I don't know if there's something wrong with his fan, but they are way wrong. So with this test, he was getting 69.7. 69. That's the 30 degrees warmer than what I'm getting. That's significant. So, I mean, what happened with his test? It's not like I can do a test where it cools too good with the same equipment. You might want to check that fan that he has. I can't tell in the picture, but that fan might have red blades. If it is, that's not the right. That's not the stock fan. See, this is about where I think it's going to slow down. It's not going to get much cooler. Okay, what I'm going to do is just stop this video, let it sit here and cheat for about 10 more minutes. Is stable between about 38.2 to 38.4. That's where it's bouncing back and forth between. Go ahead and put our cold weather kit on here just to test this. Yeah, it's a kit. It includes 3 pieces of tape. Alright. So there's a tape on there to direct the airflow a little better. Trying to touch the nozzle with your finger when it's 250 degrees. Alright. So it is definitely making a difference at 250. I would expect the hotter that the hot end gets, the more important that the cooling would be. So directing the air better is going to blow more heat away. Yep. So we are dropping with the tape on here. Just shows you how inefficient this cover is. I suspect you'll be looking at the same 1.5 degrees with the tape on there. So I'm going to go ahead and wrap this up and edit it. I think it's pretty consistent. All the testing was pretty consistent with each other. The ranges are right. The difference increased a couple degrees is what I predicted. So, all right, guys. Good luck. Don't worry about your screws.